so here's number one. Let's let that load up here. Have you done both law of sines and cosines, or just one or the other?
Both of them.
Both of them. Okay. All right. So what your teacher is looking for at the end is essentially a table: A, B, and C. That's for the angles. Little a, little b, and little c. And you obviously have some of these already. It's good to kind of populate these here. So in this case, how would you find angle B if you know the two other angles in the triangle?
So you would add 66 and 61 and then subtract from 180.
Yes,
and you
exactly.
would get 53 degrees.
53, good. Okay, now that's very important. All right, get those down first. All right, so this is a law of sines problem because you have an angle and a side pair. Didn't realize that I had put C there again. Let me grab this. C is 23. So because you have an angle and a side pair, meaning you've got the angle and the side across from it. Okay, you're going to want to use that in the law of sines. All right, so we can actually find either A or B. Let's just find A here. So you might write it this way. You always write the thing that you're trying to find A over, in this case, sine big A. And then what do we know? We know little c and sine big C. Okay, like that. And then you fill in the numbers that you know. You know that it's A over sine 66 equals C 23 over sine 61, like that. Is it clear how I substituted those numbers into the formula?
Yeah.
Awesome. Okay. Now sine 66 and sine 61, they're really numbers. You can put them into the calculator now. I would recommend waiting. You want to clear this sine 66 out of the bottom. So you're going to actually multiply both sides by the sine of 66. And you see those cancel. So your final answer here is A equals 23 sine 66 over sine 61. All right, so if you got a calculator, go ahead and calculate that out. Sometimes that is the major issue, is just making mistakes when you put it in to the calculator there. So
that would round to 24.
Yeah, what does it want you to round to here? Nearest
Nearest
10.
whole.
Nearest.
Well,
it says 10.
Yeah, because on the last quiz he told us to do it onto the 10th, but for some reason on this worksheet he wants to do it to the whole. But 10th would probably be what he wants on a test or something.
Okay. All right. So the nice thing now is to find B. It's kind of a rinse and repeat. You tend to want to use the given information, but you know, when we find B, it's basically the same process here. We're just doing B instead of A. So sine big B equals C over sine big C. So it's B over sine. I think you said 53 degrees equals 23 over sine 61. And same thing here, you're going to clear out that sine by multiplying both sides by it. Okay, so you end up getting that B equals 23 sine 53 over sine 61, like that. And this one actually does work out nicely. 21.0. So if it were me, if I could go back in time as a student, I would present my information in a nice table. It makes it easy to grade. They don't have to search for the answers. I've also shown my work.
So he does the same thing, except he puts the signs on the top. So instead it'd be sine over side. So it'd be sine A over A equals sine C over C.
Right. The formula can be written a couple of ways. So if you're solving for an angle, then you would write sine A over A equals sine B over B. And then the last part is sine C over C. If you're solving for a side, it's A over sine big A equals B over sine big B equals C over sine big C. Okay, so it depends. It really depends. And I always prefer to put the thing that I'm solving for in the top left. That's kind of my preference here. All right, so we should look at another problem here, I guess. That's okay with you?
Yeah.
All right, so number 2 here. I do like that you've labeled the sides. That's a good thing to do here. All right, so again, you gotta look at what you're given. And that's why the table really does help here. A, B, C. We know that C is 75 degrees, little a, little b, little c. We're given little c is 35 and little b is 13. So if we're given an angle and a side pair, you can use law of sines. That's one of the requirements here for it. So because we don't know angle B, but we know side B, we're gonna shoot for that first. So that's why this time you would write sine big B over B equals sine big C over C. All right, so again, you're just mapping the numbers there. Sine big B, we don't know, but little b is 13. Sine 75 over 35 like this. So to solve for angle B, you're going to multiply both sides by 13. So you're left with sine B equals 13 sine 75 all over 35. Okay. Do you remember from class how to undo sine?
Reverse sine.
Yeah, I mean, in our language that sounds right. It's called inverse sine in the math world.
Yeah.
So I'll show this one time, but so you would literally write sine inverse of sine B equals sine inverse 13 over 35 sine 75. And then on the left, it just cancels. So it's sine inverse 13 over 35 sine 75. Now, what most students do is they just go from one line. They skip this intermediate step because it's you can write it, but it doesn't really add anything to it. So if you can enter all that into your calculator at one time. If you don't like that, you can do it in pieces. The main thing is that you get the right answer, and also important that you have your calculator in mode of degrees for this, which I know you do because you've already given me some correct answers. So what do you say here? What is the correct answer for this one?
Hold up. 21.0.
Yes. And we feel really good about that. We got B is 21. We go back to our table, we fill that in. Whenever you have two of the three angles, you can easily find the third with subtracting from 180. So I believe this will be 84 degrees. Any questions on that?
No, pretty straightforward.
Okay. Now to find A, you're going to use law of sines again, because you have an angle and a side pair. This time you're going to put the thing that you're trying to find, the little a, in the top. So it's A over sine big A, and you can use either B or C. I always go back to the given values rather than the calculated ones, just in case there was a mistake by doing that. So that's my preference. So it's C over sine big C. So it's A over sine, what did I say there? 84 degrees. Sorry for all the scrolling. Equals 35 over sine 75. And then you solve for A just like we did in the last problem by eliminating that sine 84 on the bottom. So 35 sine 84 over sine 75. Okay. Go to the calculator here.
I got 36.0.
Yeah, it's kind of amazing how these all work out to the nearest whole number. Any questions on that?
No, it's pretty easy.
Yeah, not too bad. Let's see here. So for number 3, do you mind reading it? Because,
So
well,
it gives you 3 of them. So it'd be angle B equals 66 degrees, and then side A is 16 and side B is 15.
yeah, so let me sort of write there. So the measure of angle B is 66 degrees, A is 16, B is 15. Is that right?
Yeah.
All right, now what I recommend is drawing the same triangle every time, even though it's might not be to scale, and then labeling it the same every time. Okay.
Yeah, he's really particular about how to draw these.
Oh,
Like he
really?
wants them to be drawn like really accurately.
Okay. That is definitely not how I show this, and for good reason. It like, how do you know? It's kind of like looking up a word in the dictionary. If you don't know how to spell it,
Yeah.
you wouldn't know where to look. You don't know what the other angles are to know, so you can't draw it accurately until the end.
Well, the reason why is so this one it's angle side side, so it has 2 different sets of answers, right?
Maybe we don't know yet. We will find out.
Really?
Yes,
He always taught me that angle side side meant there'd be 2 of them.
not always. I mean, you got to be careful there. It could be. It could also be that there's no triangle, depending on the numbers. I mean, we don't know anything. I mean, all we know is there's an angle that's 66 degrees. So let's assume that that's 66 degrees. And we know that the side here is 15. Okay, that's 15. That's all we really know. We don't know where A is, and we don't know where B is, because it could be that, like we mentioned, it, well, that's not quite right.
Yeah.
So like what you're trying to do here, I mean, if you had a compass or protractor, I suppose you could do this. I'm suggesting not to do that right now. Um, we can go back later and do that, is I guess what I'm suggesting. So let me show you this, because I think you'll appreciate this when you're done, and then we can go back and draw it correctly if we need to. So measure, so first thing we're going to find is A. So we're going to go sine A over A equals sine B over B. So we have sine 66 over 16 equals sine of the unknown over 15. Now, I kind of violated my own rule here. I really should have put the unknown in the top left, but that's okay. We'll just switch around here. So sine B equals 15 over 16 sine 66. And then you take a sine inverse. So sine inverse. Okay. So after we get this angle, this is where we check to see if there's a a second triangle. All right, so I get 58.9. Could you confirm that though?
Yeah, 58.9.
All right, so here's what you do next. You subtract it from 180. Which is 121.1. Is that okay?
Yeah.
Now you go back to your previous angle, 66, and you add 66 to this, and you see if there's room, meaning is the sum less than 180? If there's room, it'll fit. The other angle will fit. You can see pretty quickly here, you don't need to calculate this, 187.1. There is no room for this. So there is not a second triangle.
Wait, because on the answer sheet it shows that he has another triangle.
Well, I
So
mean,
what he did was he did sine 66 over 15, and that equals sine A over 16, and then that became 77 degrees.
did I use the wrong ones here? B over B. Let me check this with another thing. There's a lot of online calculators for this stuff here.
Well, you're trying to find A because the given is angle B. So you know that B is sine 66 over 15 because side B is 15.
Yeah, so there are two. So I made a mistake somewhere in the calculation here. I don't understand. Measure of angle B is 66, A is 16, and B is 15. Is that right?
Yeah.
Maybe I calculated that wrong. A sine D. Oh yeah, I did. It's 16 over 15. That's why it's not working. Sorry, the screen kind of glitched there. Yeah, so it's 16 over 15, 16 over, and that changes this number here. So let me recalculate that. I mean, that's why I always get to check these because yeah, so this one will work out a little bit better. So here's how you do it. Again, you get that angle, it's 77.0.
Yeah.
You subtract it from 180, okay, and that's 103.0. And then you add the 66 and see if there's room. In this case, there's room. There's 11 degrees. So yes, there are two triangles. Okay, so this is where you have to make two tables. You've got A, B, C, little a, little b, little c, and then you have A prime, B prime, and C prime. They're not all changed, but it's good to sort of denote that there's these differences. So in our given one here, one we started with, we found that B is 66, and then why am I so off today? We're finding A. That's why this is all messed up. A is 77, not B. This is A. Sorry about that. A is 77, and then A prime is 103. Is that clear, or did
So
I fumble that up
is
a little
it,
bit too badly?
so it'd be 180 minus 77. So is it always the 180 minus
The calculated angle.
the
Yeah.
calculated angle? Okay.
Yes. Yes. All right. And then that's where you get the second angle, but you have to check if there's room, and there is. So in this case, you can find the missing angles for both of them.
So C would be 37 degrees.
Yeah, and it's not really that they're all primes. I guess that might be a thing to check with him. I like to completely distinguish the second triangle from the first one, but you're welcome to, like the only difference is going to be in A, because A was the only angle and then C. So I mean, it's up to you if you want to distinguish them all.
Yeah.
So unfortunately, you got to go back here and find, you have to do more calculations here. So to find little c, you have to use law of sines. To find c prime, you have to use law of sines. So c over sine big C is b over sine big B, like that. So we'll do that one on the left here first. So c over sine 37 equals 15 over sine 66. And it looks like when you do that, you get about, well, 9.9, 10-ish. 9.9 for C. And then for C prime, it's basically the same calculation. C prime over sine 11 equals 15 over sine 66. And that should be about 3.1.
Yeah.
Okay. All right. So you really want to, make sure your answers are clear, that there's two triangles. Kind of makes it nice and easy to grade for them.
So he wants us to actually make a diagram for the second triangle too.
Yeah. Right. So the way to do this is, so I think the given angle is the one that's always, they always want you to do the given angle down here. This is going to be 66 degrees. And so case one is the acute, kind of the acute angle, where that's the 77 for A. And then case two, sorry, that's not quite right. Should be a little, so basically it's the second line. Let me try and draw it here. The second line, one of them gets drawn like that, one of them gets drawn like that. So I don't think I've done a good job with this first one of giving you what that looks more like the second one. So let me restart here. I'm shocked that you have to draw these.
Mhm.
Okay, so that's the 66 degrees. And then when you come back, that's going to be the 77 degrees, even though it may not look like it. And then when you draw the 66 degrees again here, the one going the other way is the 103 degrees. And then, wait. I have not drawn these very well. No, I'm doing this wrong. I'm sorry, I'm doing this backwards. Okay, this is A down here. This is 103 degrees, and this is the 77 degrees. So there's B, there's A, and there's A, and then C and C. So you can see that C in one case is really small, the 11 degrees, and then in the other one it's 37 degrees like that. So I know fumble that real bad, but you always draw the given angle down here. That's the same in both of them. And then it's always that this vertex point up here, you either draw it sort of acute and then sort of obtuse, is the difference.
So you split the original by making an equilateral triangle.
I'm just drawing it roughly I mean, it's not equilateral, but it's roughly got this shape where it's, to do this correctly, you need a protractor and a compass. Like you have to get this angle perfect. You have to bend this angle perfect and so on. I'm trying to show you that this one down here is obtuse versus an acute angle.
Yeah.
And there's some good visuals out on the internet where they like show you this red line sort of swinging out to the right, and that's how the other triangle gets produced.
All right, I got that.
All right, so let's tackle another problem here. I have 5 next, is that right? If there's a 4, I don't see it. You can also just
I might want to send. Yeah, I might want to send you 4. Actually, well,
you can, if it's like 3, you can give me the information.
yeah, it's a given triangle. So the angle A equals 68 degrees, and then side B equals 10, and then side C equals 18.
Like this?
Yeah.
Okay. This is a law of cosines now. Okay. And the way you know is you're given 2 sides, B and C, and the angle between them, A. Does this also have to be drawn correctly?
Yeah, it does.
Okay. All right. So again, like I would never, the reason I don't want you to do that is because you just want to get the numbers first, and then you can kind of make sense of them. So A is 68, B is 10, and C is 18. Okay. And this sort of leads you to finding side A to start. All right. Now there are 3 versions of law of cosines, but they're really all the same. A squared equals B squared plus C squared is one of them. So basically you put the side you're trying to find, or the one that's opposite the angle, here, okay, equals B squared plus C squared minus 2. And then it's always these 2 letters for this on the right hand side. So it'll be BC. And then cosine, it has to match up with this letter here, big A. And that's how you remember how to do it. Even though it's got all these other forms like B squared equals A squared plus C squared and C squared equals, it's really always in such a form where the side you're trying to find, or if you're given all 3 sides, the angle you're trying to find matches this letter over here. What the other 2 letters here minus 2 times the other 2 letters, and so on. Okay, so you have a choice here. Like some students like to put the numbers in to start. You can do it all at once. You could do it in pieces. A ends up being the square root of 10 squared plus 18 squared minus 2 times 10 times 18 cosine of 68, like that. There are not going to be 2 triangles here. There should just be the one.
Can I just put this all in my calculator, or do I have to
Yes,
do this a specific way?
it will do it all in one step.
Okay.
So yeah, go ahead and give it a try. You should get 17. Can't believe these are working out nicely.
Yep, 17.0.
Okay, now the nice thing when you have the 3rd side is you're done with law of cosines, because you now have an angle and a side pair. So that's again where I go back, making that table ABC. Little a is 17, little b is 10, little c is 18. And then it's like, okay, if I want to find b next, I'm going to put sine b over big B. little b equals sine A over little a. So since I'm trying to find b, I've got to know the side b. I have another angle side pair to work with. So substitute your numbers in. Sine b equals 10 over 17 sine 68, and then you can take a sine inverse for that.
Uh, 33.0, or actually would it be 33.1?
You're a little ahead of me here. Give me just a moment to get final calculation. Yeah, 33.1. And then you subtract from the two given angles from 180 to get the last one. $78.9. Oh, I guess you did send this. The number was cut off on the problem numbers cut off. So if we needed to draw this more correctly, which you mentioned, you got to start with one of the angles. So I would probably start with the biggest angle, I guess. How does that work for you guys? Is that okay?
Yeah, he wants the biggest angle on the bottom left.
Okay. Wow, there's a lot of specifics.
Actually,
Okay.
no. He wants the longest side to be the hypotenuse.
It can't be. You can't. I mean, there's no hypotenuse here. It's not a right triangle, so it must mean something different.
Yeah, even I don't know.
So let's just say that this is about 78.9 degrees. Okay. It is the longest side is across from that. That's for sure. And then you've got to kind of decide here. Well, where is A, and where is B? So I would put the next biggest one kind of on the lower right, because you can kind of, like, if that's 90, that's 45. You can sort of be like, all right, it must be about there. And then you can sort of get them to match up. So this is 68, this is 33.1, and then you can get the sides, roughly correct, like that. But it's already drawn. I mean, he's already given it to you in that picture. So, I mean, I don't know. I guess I would get my compass or protractor out and make sure that that actually is a 68-degree angle. Maybe push back a little bit on the teacher.
I don't think he wants the angles to be exactly specific, but he just wants them in the right place. But as far as where the right place is for him, I don't really know where that is.
Okay, so that's good question. That's a good question to ask. I recommend getting that down, because I mean, you can do all the work, and if you don't know how to present your answer, you won't get credit for it, which is bad, very bad.
Right, got that.
All right, number 5 here. All right, so we have 3 sides are given, 27, 28, 25. So law of cosines, there's 2 cases: whenever you're given side angle side, or when you're given all 3 sides. For law of sines, you need an angle side pair. And in both cases, they can be used to find an angle or a side. But with law of cosines, you're using this one to find a side, this one to find an angle. So I guess we could draw the triangle again, but we really don't need to, because we know we're going to just find a first angle for it. So which angle do you want to find, A, B, or C? Really doesn't matter.
We can start with A. I think that'd be the easiest.
Okay, so we can write A squared equals B squared plus C squared. Okay, that's the first part of it. Minus 2BC, because B and the C are on that side, so they got to go over here. Cosine of A. So we're now solving for cosine A. And this is probably actually a better example. Students want to put the numbers in first. You're actually better off solving for A and then putting the numbers in, so you don't have to rewrite them a bunch of times. This is more of something you might see in like physics, where you do it symbolically and then did that. So if you don't mind, I'd like to at least show you that here. You're going to subtract B squared, subtract C squared from both sides. So it's A squared minus B squared minus C squared equals minus 2BC cosine A. And then you divide both sides by minus 2BC. Okay, those cancel. And then you take the cosine inverse. So A is the cosine inverse of A squared minus B squared minus C squared over minus 2BC. There are implied parentheses in the numerator and denominator. And that's important when you're entering it in, because it's really easy to miss a parenthesis and obviously get the wrong answer. That's no good when you get the wrong answer. So got minus 2 times 25 times 28, like that. So a bit of effort there to so let's take a look here. Get that in the calculator. Let me know when you get what you get for that.
Yeah, so whoops, minus 2. So I got minus 680 divided by negative 1400, and then I got 0.485.
Okay, you get
Or point,
your calculator can do all of this. If you follow the parentheses, open, open, close, slash, open, close, close, you'll get the final answer. You can do it all at one step.
the final answer would be 60 or 61.
Yeah, 61 is good. Okay. So we know that angle A is 61. Make a little table here. A, B, C. We are not given any other angles, unfortunately, but little a is 27, little b is 25, and little c is 28, like that. All right, now you only use law of cosines one time, because you can now go back and use law of sines, since you have you have an angle side pair. So we'll find sine b over b equals sine A over A. So sine B over 25 equals sine 61 over 27. So sine B equals 25 over 27 sine 61. And then you take a sine inverse there. You can put all that in your calculator in one step there.
I got 54.1.
Okay, I would just call it 54. Find the third angle. You just subtract from 180. You don't want to use law of sines again.
65.
Yes.
Can the law of cosines one ever be two, or is it always just one of them?
It's just one. So like the path, there's like some paths here. Like if you start with law of cosines, you only use it one time, and then you use law of sines to find the other one, and then use the 180 subtract angle.
Yeah.
You could,
Okay.
and if you start with law of sines, you could use it twice. I mean, that's a possibility. There's also the ambiguous case, but you it depends on the problem, I guess.
So for this one, when he made us draw it, he made us write 28 is the hypotenuse, and then
So you've said that a couple times here. Like, let me just make sure, because this is very important. The hypotenuse is only for a right triangle.
we're
Like that, and maybe you mean the opposite, angle or side across from, but the hypotenuse is reserved for right triangles exclusively.
yeah, I meant the opposite. So
Okay.
the longest side would be 28, and then yeah,
So like, and I think that's consistent with what I was saying. Well, make the first angle, whatever the given angle is, that's not going to work. Let's do, it's gonna be a little bit taller, make that one 65 degrees,
yeah,
and then make this other one on the right here, this next biggest angle, which is 60. Yeah, I don't know. Is that 60? I'm not sure. Yeah, maybe that's 60, and then that's 54. I mean, it's pretty close to a equilateral triangle. So, I mean, unless she's getting a compass protractor out to measure, I mean, I don't know how you know for sure. And then, sorry, that's 25. And that's 20, 25 and 27. Do you have a
he makes
compass and a
this on.
protractor?
No, I don't.
Okay.
But he makes them all scalene triangles.
Okay. Well, again, that's probably something to ask, because this one's definitely not scalene. This one is, I mean, it is, I'm sorry, it is, but it has like a lot of people think of scalene as being acute. I mean, they're, like all of this triangle is more of this shape than this one off to the right. That's an obtuse scalene on the right.
Okay, so the way he makes us draw it is, see, so the one on the right, instead of the bottom left being an obtuse angle, he makes it a acute angle.
Yeah, well, that's more like this one then.
Yeah,
I mean, okay, so Jane, I mean, full disclosure here, like you're like, he's being really, really specific. And I mean, I'm not gonna be much help drawing these things. And I know I'm here, I know I'm supposed to be here to help you, but like, I'm just not gonna be able to give you help drawing. I mean, it's on a digital screen. You got to copy it down. I mean, there's like issues there. I would
yeah,
really
I can just ask him.
go back to him and say like tell me what I need to know to draw this. Like, I know how to do the calculations, I know how to get the numbers. What do I need to know to draw these things? How do you want me to draw them?
Yeah, because on the last quiz, I didn't draw it right, and then he took off 10% for it.
Yeah, that's pretty tough. But you'll see that
Yeah,
in other classes. You'll see like, oh, you didn't put it in APA format. Well, I'm not even going to grade it. I mean, I've seen that from teachers. So you got to do it the way they want. I don't have the ability to sort of, I mean, I can help you unpack it, but please get some more information so I can do that for you. Maybe like take some notes, start to finish of what he wants.
Yeah.
All right. Any other, probably could stop here. I mean, unless you got something quick you want to talk about or.
No, this is like really easy.
It is. It's not as hard as they make it out to be. I mean, there's the one triangle, there's the two triangle case, and then there's the zero triangle. And we didn't see any of those, but you might ask about that, or maybe we'll see one tomorrow, where they give you like an impossible situation.
Yeah, I think the zero triangle would be like something is over 90 degrees or something like that. On one of my homeworks, there was a triangle that was a zero,
Yeah.
or it didn't work.
Yeah. I had a student in geometry and this side was like 12 and then this was like 27. And the teacher said that he should just do the problem anyway, even though it didn't. I was like,
Yeah,
well, it doesn't
ridiculous.
work. It doesn't work because this was a straight angle. So it was even more ridiculous. But anyway, no big deal. All right, well, let's go ahead and stop here. I know we've got a lesson tomorrow, so